Hello, this is Mensaflow. Okay, on this tutorial, it's quite important to understand, but it's going to go into the prompt, vectorial database, and then the overall RAG infrastructure of how we do this at Mensaflow. So it's very critical to understand, because very often you'll say, but I put this in the database and I don't want to put this as a document in, and it doesn't understand what I want, and it's giving me the wrong answers when the LLM responds to your query. So if you don't do this right, it's going to give you wrong answers. Maybe, depending on how complex your query response is going to be. So we're going to go through this. So first of all, let's understand how to build the prompt. The prompt isn't just what you type into the chat box, but what we do here is there's what we call system prompts. So when you build a prompt, it's a whole set of series of data. So the first thing we do is we put in the system prompt, which could be rules, system rules. Then we put in a context where we search the vectorial database to find contextual data for the LLM to properly answer your question. Then there's what we call the response rules. We have pinned documents. We talked about this earlier, where we pin the document where it goes into every prompt. That's why you don't want to pin every document. Then there's a chat history. So very often when you type in something, you need to understand the history, at least in that particular session. And then the user prompt itself, whatever you typed into the screen. And then if it's too big, we have to compress it with relative compression. And then we send it to the LLM model. It thinks, and then it renders a response. Now you can actually make this self-learning by using N8N workflows to take responses, and yes, there's hooks in there, and you can then update the vector database with responses that have already been given, and it basically self-learns over time. Be careful though, so you need some keyword filtering, otherwise you fill up your database with a lot of irrelevant data that will just confuse it. And so let's get into that. First of all, let's take a look at that system prompt, where you would put that into the system. Okay, what I've done is I've logged in already as administrator here, but I've selected the Mensaflow workspace, and I've clicked the gearbox to get me to the chat setting. Here's where you can set up your LLM. We'll have more on that later. Chat mode and query mode. One is a chat mode where you have history involved, where query you do not. And you can specify the number of history you go back. If you put it too big, then it makes the prompt big and huge, and then you have a problem with the tokenization and the sizing. Here's where the prompt, this is where you put the system prompt in. Okay, so basically you can put anything in here, and basically this means it'll go in with every prompt that you make. In addition to this, we put a language prompt. It's automatically in the system. Here's a response. If it can't find anything, there's the response it'll give. A couple other things here, and that is the temperature. The temperature is anywhere from 0.2 to 1, and that gives you how much you're going to allow the LLM to hallucinate and try to guess what your answer is. The higher the number, the more it tries to guess. Be careful, because it will hallucinate on you. We usually set it 2 for really tight stuff. If you want it to be a little bit more verbose, then set it to something like 0.7. Now this is quite an interesting feature here. This is the diagnose feature. We'll turn it on, and this is a diagnostic feature which we'll do to test to see if all this thing's working. So that's kind of an overview of how the prompt is constructed. But let's look at how we talked a little bit about the vector database, but we want to then see how, in fact, we build the vector database, because the data in is obviously garbage in, garbage out, so we have to make sure the data is correct. So when we build the context of the RAG, we first look at the document. You don't have to pre-clean it. It depends on the data structure or how confident you are that the LM can actually figure it out, the data out. But sometimes it's useful to pre-clean because you get better responses out of the RAG. You upload the document, as we've seen before. The Mensaflow system chunks the documents, calculates the chunk vectors, and then embeds it into the vector database. We've gone through that process in the document management section tutorial. And then when the user puts in their prompt, it vectorizes the prompt, and then you match the vectors. It also does we do a hybrid contextual search, so it's text and vector. We score it and filter it, and kind of a compression process, and then we include that as context to the LLM query, to the LLM model. Here's a little bit more detail of that. You can see here we can pre-clean the documents. That's a question mark. Don't have to. The documents goes in. We've seen that process. It goes into the chunker, and we create chunks, vectorize it, and then when the prompt comes in, it matches those prompts against the vector, scores it, sorts it, compresses it, and then provides prompt context. So that's a bit more detail. So it's interesting to note there's some overlapping here, and this chunk size is very critical. So let's go into the system and see how that's set. First of all, it's set up on the server to have the appropriate embedder. Now we use a local Ollama embedder. Now you can buy with APIs, you can use other embedders. Not sure it's worth it, but you can actually buy embedders, but of course that's a paid service. One of the ones that we use is this Nomic embedder. It has an embed chunk length of 768, and then it does the embed internally, and then you look at the splitter. We split it into 768 in terms of the model, and of course you have to match that to the model. If you put them, you can't. These numbers have to match what the model says. If you go into to the Ollama that'll tell you that this is a 768. There are other models, depending on if you have a lot of data or less data, you have to decide which model you want to use. So once again, we're into the Mensaflow workspace. Again, you can get here from the system admin, or you can get it from the manager. The manager, obviously, of the workspace can only get to their own workspace. So we're in the vector database. Basically, there's the things you set up. You can reset the database, but if you reset the vector database, be aware that you destroy all the vectors of the documents that you inputted, and it has to be re-embedded with new. For instance, if you change the embedder, you then need to also re-vectorize it, because obviously the vectorizations won't match the prompts as they come through. And you can see here that I think I put in documents. I think there's about 4 or 5 documents, but it made a bunch of chunks, and it's made 115 chunks, as you can see. And then we say you can sit there and specify the number of chunks that you want to be included in the context. Obviously, the bigger they are, the bigger the prompt, and you might get compressed, because you can't just put everything in the world to the LLM. You have to squeeze it into the token size, otherwise, and of course it does cost more and more token it costs if you're using an API. If you're using local, it's just a matter of how much resources on your local server that you use up. Here we kind of set about at 4, but sometimes you want more context. You make 6 or 7, depending on the size. But this 768 pretty low chunk size, so you could probably increase it if you want, but I wouldn't go more than 6 or 7. You'll see this more when we go into the diagnostics of the system. I'm going to go into a little bit how we pre-clean the documents. And this was kind of in our Mensaflow, we have this kind of a mock sample of Quality Motors who is going to do car repair. Of course, it does it in French, English, or French. I'm going to do it in French here, just so of course, there's reasons why you might want to do this, because if you're speaking to it in French, it may or may not, the LM will try to do some language translation, but it may not. So the more data you can give in specific languages, you may be more useful for your LLM context. Here you can see we're gonna look for an oil change here in CSV file. Now there may be, for this Quality Motors example, there may be hundreds and hundreds and hundreds of different kinds of repairs. Of course, here's your standard CSV, the language, the problem type, what the repair was, and the repair they actually did, and the cost. So you can see here, we're going to replace the oil filter here. That's what that means in French if you don't speak the French. And you can see where that follow through. That's what the data looked like. But then when you actually do the clean, you may want, because you see the header of this CSV is only on the first line. You don't get it all the way through. So what you may want to do, and this is just an example, to clean the data through some kind of programmatic mechanism. So you take each line and you give the full context of each line with because remember, these will be chunks, and you may get a chunk at the bottom of the CSV file, may not have the context of the CSV header file. Here's just a quick example if you need this piece of code. I think Claude wrote this. You can get Claude to write it for yourself, but basically what I do is I convert the CSV file into more of a contextual data to be inputted into the vectorial data. So when it goes in as a chunk, it goes in as a JSON file, and of course the Mensaflow software does all this for you. You don't have to do that. I'm just showing you the details under the hood so you can see what it's doing. And you can see here it vectorizes this particular JSON chunk, and it vectorizes. I don't show you the actual vector numbers because that's buried deep inside of the LanceDB vector database. But there it is there, the 50 euros for the oil change. That's what we're going to query for. So we're going to test our data here. And again, we hit the gearbox, and we go down and put it in the diagnostic mode. And we say yes. And what that'll do is it'll let you do the administrator prompt, and it will do it in a diagnostic mode where you can actually see what's going on inside the system. Okay, so here we are. We click this Mensaflow bar. We're in diagnostic mode, so it gives you the kind of a detail what you can copy and analyze to see what you're doing here. So I'm going to ask it in French, combien changement de huile pour ma voiture. So you misspell a few things, but that's okay. So we're going to do that, and it's going to come up with a long list here. Here, this is the answer it gave. It's around 50 euros, which is exactly what our data said, if you recall from the previous video. So how did it do that? So let's go back to the top here and see this whole prompt. Here is the 4 chunks that we had. Those are the 4 chunks. And you can see it got it out of the right file. This is the file it got it out of. It scored it. Got a pretty high score. Usually the scores go up to 1. Anything over 30, 40, 50 is generally pretty good, and it even gives you the context of the and it's obviously the first match. So you can see there it got it. So that's going in as a high scoring vector search, and so it found the right vectors there. You can see that. So we go down, it got some more stuff there, but it's going to do that. Here's our system prompt, and of course we've set it's set to English, we set it to English, so I should have reset it, but it gives you the system prompt there. Here's the pin text. That's from the pin document. As you can see, that goes into every prompt that we talked about. Here's the chat history, and I had some chat history before. It was a bit nonsensical. And then here's the prompt that I put here. Combien de changements de lieu pour ma voiture. Okay, and then use all that previous context to give to the LLM, and so that makes the LLM know he can see all that. Now, if it gets too big, I mean, if your search gets too big, it depends on. Here's the max tokens. I think we're set to 16,000 tokens. A token is about 4 to 8 characters, depending on the size of the words. It tells you some information about how it compressed. So here's the context items. It had 5, kept 5, it skipped 0, history message 10, 10, and skipped 0. Now, if you have a long history going on, it'll start trimming that back. It'll start sorting. It will start sorting the contextual and start trimming it down to fit into the 16,000 tokens. You can see here that we're a long way from it. This is a simple prompt, but if the prompt gets quite complex, this will matter. It will start trimming off the lower scored contextual information. Very important. Of course, you can turn this diagnostic off. We turned it on, but you can turn it off and just talk to it normally. On this, you can copy this so you can analyze if it's actually seeing the stuff that you put in to the vectorial base is actually being searched, and you get the citations here. Here's the rules file, and remember, here's the rules file that we had. It may mean nonsense to you because we were using it for different things. And then here's the chunks that it's getting. So you can kind of see that on the citations. So we can see that the RAG is properly getting the right information that you put in, and you're going to get a better quality of output when you follow these rules. Anyway, I hope that was useful to understand the prompt, the RAG, the vectorialization, and how all that fits in to get the right answers out of the LLM. Anyway, don't forget to subscribe and click the like button on your way out.